Greetings, ladies and gentlemen. Welcome to Nostec Academy. In this video, we're going to revise Mathematics Paper 1. Maths Paper 1. Okay, Mathematics Paper 1, we're going to start with 2017 GCE. So, 2017 GCE is just paper 1. Yeah. So the very first question here, we are asked to simplify. Okay? Simplify simplify 2a minus b minus 7b rather 7b minus 2 open bracket a minus 3b close bracket, and this one is 2 marks. Okay, so solving this question is easy. The key is here, the number which is closer to the brackets. So what you do, you copy the way these are, like this, 2a minus 7b minus 2a minus 3b, then you start solving. Okay, so we will solve by multiplying the number which is closer to the bracket, which is -2. So -2 will be multiplied by everything in the brackets here. So we're going to maintain here 2a minus 7b, then -2 times a will be -2a. Negative times negative will be positive. 2 times 3b will be 6b. Okay, it is as simple as this. You just expand here. Then when you reach this stage, you collect like terms. All right, so here there is an a, even here there is an a, there is b, even here there is b. So you can collect them or group them. 2a, this will be minus 2a. Y is still minus when it's changing position. Changing position when it's not crossing the equal sign, the sign doesn't change, so it comes the way it is because it's not crossing the equal sign. Then this one will be just -7b plus 6c plus 6b. Then you can solve 2a minus 2a, this is just 0. Then -7b plus 6. What you just need to know here is that when you have two numbers with different signs, like here, just subtract, then get the sign from the bigger number. When you subtract 7 minus 6, it will be 2. The sign from the bigger number, which is what? Negative. So here, -7b plus 6b will be -2. Not 2. This will be 1. Sorry, this will be 1. 7 minus 6 is -1. Is 1. Then the sign from the bigger number is 1. So here is 1. Then the common letter here is b, but you can't write 1b. You just write -b. Okay, as simple as this. Let's go to the next question. The next question in this paper is which is question. So this one was question what? Question 1, and this one is question 2. So question 2 asks to factorize completely. Factorize completely x squared over 4y squared minus 1 over 9. Okay, 2 marks. So when you're asked to factorize, the first thing is to look for common factors. What is common between the two terms? So you will notice that there's nothing that is common here. So you can say we can write x squared minus 4y squared okay, minus 1 over 9. Then what you do here, since you don't have what is common, then check for differences of for squares. So if you check here, this 4, let me just write this, x squared, this 4 can be written as 2 to the power 2, okay, and this is y to the power 2 minus, this 1 is the same as 1 to the power 2. This 9 can be written as 3 to the power 2. This is the square of 3. Okay, now we have everything squared and they're separated by minus sign, which is the difference of two squares. What you do here, you write one of the x's here, then one of the 2's y, you do the same, then plus 1 over 3, okay, like this, then open bracket, the remaining numbers and variables. So we have an x, 2, y, in this case minus. Okay, start with minus or plus, okay? Otherwise, as long as they are of different signs, then 1 minus 3 squared is the same as, we're remaining with another 3, like this. So this is the answer. We factorize this question completely, okay? Then question 3. Okay, let me just clear some space here so that we copy question 3. Question 3, okay, given that 2x -5, 1, like this, multiplied by 4, 3 is equals to 14, 17. Okay, find the value of x. Find the value of x. This is also 2 marks. All right. If you are done copying the second question, I can erase to create more space for solution of question 3. For question 3. Okay, so question 3 is matrices. So since this is a multiplication, you're multiplying this matrix times this matrix, giving us this. So they already multiplied. What they just did is to remove one value, which is x. So what you do to find the value of x, we are going to do the same. We're going to multiply this row. Let me use a different color. Going to multiply this row, okay, times this column to give us this answer. That's it. Okay, then this row times the same column gives us 17, this answer. All right, so this is a 2 by 2 matrix, then multiplied by a 2 by 1. So our answer should be a 2 by 1, which is of course a 2. This one is a 2 by 1. So what do you do to find the value of x? Okay, to find the value of x. To find the value of x, you're going to say 2 times 4, okay, 2 times 4 in bracket plus x times 3, which is x times 3 here, is equals to this value 14. Okay, since we are interested in the part which will give us the value of x, then we can just do this and leave this one out. So 2 times 2 times 4 is 8. Okay, then x times 3 is 3x is equals to 14. Is equals to 14. Then what you do there, you solve for x. So what you do, the 3x will remain with the 3x this side. Then the 8 will cross the cosine. Since it's positive, it becomes negative 8. Then 3x is equals to, then 14 minus 8 is 6. Then divided by 3, divide this one by 3, and x is equals to 2. All right, x is equals to 2. So if you want to prove that x indeed is equals to 2, plug in 2 for x here. So if you plug in for x, it will be 2 times 4, 8, plus 2 times 3, 6. Then what is 6 plus 8 is 14, which is this answer. So this answer is correct. Okay, let's go to question 4 of 2017 GCE paper 1. Okay, so question 4. So question 4. So you pause the video when copying. You pause the video, you copy, because we don't have enough time to be waiting for everybody to copy. Or yeah. So number 4. Question number 4 is reads, two teens are geometrically similar. Okay, similar. This is under similarities and congruence. So two teens are geometrically similar if the ratio of their volumes is 27 to 64. Find the ratio of their curved surface areas. 2 marks as well. So when we're done something, this one will be having 8 marks. So two teens are geometrically similar if the ratios of their volumes is 27 to 64. Find the ratio of their surface area. So we are given volumes and ratios of their volumes, and we are asked to find area. So what you do is that whichever ratio or whatever ratios we are given, change them to ratio of their sides. So since here is volume, is ratio of their volumes, which is 27 to 64. Before you change them to ratio of their area, you need to change them to ratio of their sides or heights, ratio of their sides. So what do you do by changing this ratio of their sides? Is by cube rooting. So to be cube root of, since it's volume, then is cube root of 27. If this one was area, I would have square rooted, because the square, area is measured, the units is square units. So this one will also be cube root of 64. So cube root, it means the number when you multiply itself 3 times should give you that number, which is 727. Which number will multiply itself 3 times gives us 27 is 3. 3 times 3 times 3 is 27. All right. 64 is 4, because 4 times 4 times 4 is 64. So this is the ratio of their sides. All right. Then we can change the ratio of their sides to ratio of their area. Okay. So what do you do when changing to area, from sides to area? You square these. So it will be 3 squared to 4 squared, which gives us 3 to the power 2 is 9, 4 squared is 16. So this is the answer. Okay, let's do a little bit of proving. If at all here, this was the ratio of their area we are given in the question. We are given the ratio of their area, then they're asking us to find the ratio of their volumes, let's say. So what you do again, where we have volume, you write area. Oh, by the way, we are done. This is the answer. I'm just showing you because it's not always that they bring volume to area. Okay, sometimes it's area to volume. Now what do? So ratio of the area is say 9 to 16. Change it to ratio of their sides. Since it's area, you square root. Okay, volume you cube root, area you square root. So we're going to say the square root of 9 is 3, the square root of 16 is 4. So to find volume, you cube these. So it will be 3 cubed to 4 cubed. 3 cubed is 3 times 3 times 3, which is 27. 4 cubed is 4 times 4 times 4, which is 4 times 4, 16. 16 times 4 is 64. You see, it's still giving us the answer. So 9 to 16 is correct. Let's go to question 5. Okay, let's go to question 5. Still copying. Okay, so question 5. Okay, so question 5, 2017, question 5 reads, given that vector A is equals to 3 negative 4. Okay, like this. Then they're asking us to find the value, the absolute value of A. So if you are given such a question, what do? You are just given 1 point. Okay. So if you are given 1 point and you're asked to find the absolute value, or which means the magnitude, find the magnitude, the size of this. Okay, the size of this. So I'll explain it in two ways. So the first one is, see this. Sometimes they bring you 2 points. Now they've given us just 1 point here. If they've given us 1 point, to find the magnitude of this vector, it will be simple. It will be the magnitude of vector A is equals to the square root of x squared plus y squared. Like this. Okay? Like this. Now, if you have 2 points, let's say you have 2 points in the form of x1, y1, and x2, y2, to find the magnitude, the size of the 2 points, or the length, in short, you can say, let's say this one is A and this one is B. So you can say AB will be the difference in the x value, which is x2 minus x1 squared plus y2 minus y1 squared, like this. So this formula and this formula, that's the same. Just as this one when you have 2 points, this one when you have 1 point. Since here this question we are given 1 point, then we can use this is x, this is y. Okay, this is x, this is y. So here it will be the square root of x is 3. So we'll say the value of x there is 3. So it will be 3 squared plus, then y is negative 4. So it will be negative 4 squared square root. All right, the square root of 3 squared is 9 plus negative 4 squared is 16, positive 16. 9 plus 16 is 25. Then the square root of 25 is 5 units. Why are we using units? Because dimensions or distances are measured in units. Okay, or sizes are measured in units. So when you are given 1 point, this is what you do. The same as under coordinate geometry, when you're asked to find the distance between 2 points, this is the formula. But when you're given 1 point, use this one to find something like this. Sometimes they not say find this. Sometimes they just say find the magnitude of A. The magnitude of A is the same as the absolute value of A. So the answer is just 5. Let's go to question 6. Okay, question 6. Question 6, on the Venn diagram in the answer space provided, defined by, so shade the region defined by, so not waste time copying the whole question. I'll just write the set notation, which is A complement intersect B union C. Okay, so they're asking us to shade this one. Then in the answer space provided, it's like this. Okay, so this is A, B, and C. So there is a video I did on shading sets, okay, or coming up with set notation when you're given an already shaded set, okay. So check it out. I'll put the link in the description box. So anyway, let's solve this one. So I said, and I always say, this one is simple, though it's awarded 2 marks. It's very simple. The key is a set which has a complement. Okay, so set A has a complement, meaning we are not going to shade. Let me use a different color here. We are not going to shade this anywhere in this line. We are not going to shade. That's the meaning of complement. It means excluding. So A complement means not here in A. Okay? But remember, another key point is here. This symbol here, which is the intersection. The intersection which is here, when it comes to shading, the trick is here. If it's intersection, just know that you're not going to shade the outermost, the universal set outside here. All right? Just consider the B union C. B union C, it means unite them, put them together, union. If it's intersection, it means where they are sharing here. Okay? But union C, B union C, it means everything in A, in B, and in C, like this. Okay, like this. In B and C, like this. But remember, you are not going to shade. You are not going to shade this area because it's part of A. Okay, so this is the answer. That's it. Remember, number one, a set that has a complement. Start with that one. If there is a complement, then the intersection, you're not going to shade the outer part, outside part here. Then B union C, consider this one. Now, sometimes you might say, okay, if in the exam they just bring this, it's already shaded like this, and then they are telling us, come up with a set notation. What do? You do the reverse. You start with a set that is not shaded. The set that is not shaded has a complement. So what you do here, set A is not shaded. So you're going to say, since set A is not shaded, then set A has a what? A complement, number one. Since set A has a complement, the second step is the outer party here, the universal set here outside, shaded? No, meaning is intersection. Okay, intersection. Then what is shaded? Check. B, the whole of B, this side, and C are shaded. So it means, put in bracket, B union C. All right. Now, if only this part was shaded, this little part here, the intersection, this would have been intersection and not union. That's it. That's how you solve this. Let's go to question. That is question 6. We'll end on question. Okay, I'll tell you where we'll end. So question 6. Let's go to question 7. Question 7. Okay. So question 7, A, there's a sequence here. We are given sequence 11, 13, 15, 17, and other numbers. Then they're asking us to find the 13th term. All right, find the 13th term. And then the second one, let me write, they're asking us if the arithmetic mean of 5 and C is 11. Is 11. What is the value of C? What is the value of C? Right, this one is 1 mark, and then the second one is 2 marks. This is under sequence and series, arithmetic progression and geometric progression. Now, how can you know that this one is arithmetic progression or geometric progression? Now, it is arithmetic progression if there is a common difference. 15, then 17, blah, blah, blah. If there's a common difference, let's find the common difference. If at all we can find the common difference. Common difference is equal to T2, term number 2 minus term number 1. All right, common difference is equal to term number 2 is 13. So this one is T1, this one is T2, T3, T4. So T2 is 13, T1 is 11, 11 minus 13 minus 11 is 2, so there's the difference of 2. Then you do the same here, T3 minus T2, 15 minus 13 is still 2, 17 minus 15 is 2. So this one, there's a common difference, meaning it is arithmetic progression. Now, since it's arithmetic progression, how can we find the 13th term? We can find the 13th term by using the formula Tn is equal to A plus, open bracket, n minus 1 close bracket, D. Okay? Now, so N is the number of terms. So T13, you are finding term number 13. A is the first term. What's the first term there? 11. Plus N is what? 13 minus 1. D is the common difference, which is just 2. So T13 is equals to 11 plus 13 minus 2, minus 1, sorry, is 12 times 2 there. So we have T13 is equals to 12 times 2 is 24. So I have 11 plus 24. 11 plus 24 is giving me 35. All right, it's giving me 35 as the 13th term. 35 is the 13th term according to this formula. Then arithmetic mean. So the formula for arithmetic mean is AM for arithmetic mean is equal to A plus C over 2. Now, why A plus C? Listen, if you have terms, 3 terms A, B, and C, which one is in the middle? Of course, is B. That is the arithmetic mean. Okay, so to find this B, we're supposed to add A plus what? A plus, what's this? C, divided by the number of terms, which is 1, 2. There are 2. All right? So in this case, they're saying that if the arithmetic mean of 5 and C is 11, so the arithmetic mean, well, they're given us as 11 here. Okay? We're supposed to have A, is you're going to put 5. You're not supposed to C, to have C, you have C. Then over 2. Then you cross multiply as simple as this. So here you can also say B is equals to, or arithmetic mean. Let's just use B. It makes more sense. Okay? So B is equals to that one. If you want to find B. So when you cross multiply, it will be 5 plus C, then 2 times 11, 22. And to find the value of C, this one cross the cosine, it will be 22 minus 5. To find the value of C, finally, we subtract 22 minus 5, which is giving us 17. So the value of C is 17. Okay? That is about question 7. Arithmetic mean and geometric, arithmetic mean and the arithmetic progression. That is question 7. Okay, let's go to question 8. To question 8. Okay. Okay, so question 8. There are 2 questions. There is A, you're saying if A to the power T is equals to 1, -2, 3, -4. They're saying write the matrix A. This one is 1 mark. Let's solve it, then we go to B. So whenever you see a letter raised to a power T here, just know that that is a transpose. Okay, this is a transpose. So A transpose is 1, 2, -2, then +3, -4. Then to change this one to matrix A, to its original matrix, the first row becomes the first column. So this is the first row. So this first row become the first column. So this one, like this, will go like this. Since this is the first row and becomes the first column, which will be 1, negative 2, 3, negative 4. And this is the answer. Okay, as simple as this. That is about question 8A. Then it's 1 mark. Question 8B. So you're asked to find the derivative. So let me just write it from here. Find the derivative of what? Y is equals to 2x to the power 3 minus 2x, is this? Yes, minus 2x squared minus 3x plus 1 with respect to x, and this is 2 marks. So this is differentiation. This is calculus. So what you do, calculus here, first you check if this equation is in standard form. Standard form, it means that the powers are not negative or are not fractional powers, or else you first change to a normal, not to a fractional power or to negative power exponent, then you can start solving. So what you do here, since it's already in the correct order, you introduce dy, so say dy dx here. Dy dx, just know that this one is not a fraction, it's not dy over dx. No, I'll explain more when we look at calculus in paper 2. Now, what you do, the rule states that you multiply the power times the coefficient and the power reduces by 1. So it will be 2 times 3 x to the power 3, the same power reduces by 1. You do the same even here, it will be 2, negative 2 times positive 2, which is the power, then x, the same power reduces by 1. Here you do the same, it will be, since this one is raised to the power negative, invisible 1, it will be negative 3 times 1 x, and invisible 1 minus 1. Then the dy dx of a constant number is always 0. Alright, so dy dx here is equals to 2 times 3, 6, and it will be 6x, then 3 minus 1 is 2, 2 times 2 is negative 4, x, 2 minus 1 is just 1, which is pretty good, just leave it as x here. 3, negative 3 times 1 is negative 3, 1 minus 1 is 0, anything raised to the power 0 is equals to 1. So this is the answer, as simple as this. Okay, that is the answer to question 8. Okay, let's go to question 9. Question 9. We'll end on question 9. Okay, we'll continue in the next video from question 9 to 23. Okay. So question 9. Question 9a, given that universal set, we have 1, 2, 3, 4, 5, 6, 7, 8. So 1 to 8. So you have 1, 2, 3, 4, 5, 6, 7, 8. All right. Then from this set, you come up with set A, which consists of 1 and 8. Then set B, from here we will come up with 2, 3, 4, 5, 6, and 7. And then there's asking us to do what? To list A union B complement. Okay, simple. This is just 1 mark. This 1 mark. So this one is simple. So what you do, remember, when it comes to the issue of a complement, A union B complement, when you combine, it means without a complement, they're saying combine A and B. That's the meaning of union. Combine A and B. Then if they add a complement here, it means remove what is in A and what is in B. Write what is remaining. So A union B, the whole of each complement. If you remove what is in A and what is in B, what do you remain? What are we remaining with? So if you remove 1, 2, 3, 4, 5, 6, 7, 8, what are you remaining with here? Nothing. Nothing. So it is an empty set. It's an empty set, or you can say empty set. You can write like this: 2 curly brackets. All right. It's an empty set. Okay, if you want a more illustration on this, let me just show you illustration. So you have 2 sets, set A and set B. First, when it comes to now writing information in the Venn diagram, you start with the intersection. So we start with what is in both what is in A and B. So do you have what is A and B? No, we don't have. So in A we have 1 and 8. In B we have 2, 3, 4, 5, 6, 7. Then outside we don't have. Even what is common, we don't have what is common here. What they are sharing, A and B is sharing. So when you say A union B complement, it means remove what is in A and in B. What are you remaining with outside here? Nothing. So it is an empty set. That's why it's 1 mark. And it's usually 1 mark such questions in the exam, and they usually come. So make sure you understand. All right? You understand. Now, what if they say not A union B, but A intersection B? Okay? What if they say, because sometimes they just say A intersection B complement. So this one, it means that remove what is in A and in B, what is common, and you have nothing in common. So what you remain with when you remove what is common here, you remain with 1, 2, 3, 4, 5, 6, 7, 8. That's it. If you remove what is common, because there's nothing that is common here. Now, what if they say, if the complement is not there and the complement is just here? Remember the principle I said earlier on question 3, should be 3. That start with a set that is that has a complement. It means remove B. Okay? And just consider set A. So if you remove B here, what are you remaining with? 1 and 8. Okay? 1 and 8. The same as if the complement was here. If you remove A here, you are remaining with what? We are remaining with 2, 3, 4, 5, 6, 7. Okay? So that's it. What if there was a union? It means consider even elements that are outside, but you don't have anything outside here. So I think I'll explain more in paper 2. So let's look at this question B. Question B of under the question 9. B under question 9. B under question 9. Okay, so the second question, question B, is solve the equation. Solve the equation. The equation is 25 to the power x is equals to 5, and this one is 2 marks. So what you do when you're given such a question, so this one comes, and this one is under indices, equations involving indices. Okay, equations involving indices. So what you do is change everything here to the base of to the common base. So since 5 can't be changed to 25, the base of 25, but 25 can be changed to the base of 5. How? 25 is the same as 5 is power to the power 2. Then you have times x here is equals to 5. This 5 is the same as 5 raised to the power 1. So since you have now what is common here, we have common base, then you just get the powers when you have common base. So you have 2x is equals to 1, power 1 there. So 2 times x is 2x is equals to 1. To solve for x, we divide both sides by 2. Yes, so the value of x is equals to half. Now you can prove if your answer is correct. Plug in where x is, where 25, where you have power is 25, power is x, I mean, with half. When you're given such a question, what do? You find the root of 25. So the square root of 25 here to the power, this one, is just 5, which is this one. So our answer here is 100% correct. So thank you so much. If you've been with me up to this point, thank you so much. Consider subscribing. See you in the next video.